Thanks for joining me. I think the first thing I wanted to ask was around what you've described as the new normal that's going to emerge after COVID-19 that you're seeing emerging now. And I think previously when we've discussed this, you've talked about there both being tactical, short-term changes that COVID-19 implies and longer strategical changes. And the tactical changes were things like greater reliance on remote working, and the longer-term strategic changes were things like the way that universities plan, manage and administer their research portfolios, and a range of other things. So I guess I'm just very keen to firstly hear about what you're seeing on the ground in universities across the region that you're responsible for, and also what you think the new normal might look like as we emerge from COVID-19.
Thanks, Tim, for this opportunity. Let me describe a little bit about how we have seen this evolving. So when the COVID outbreak in Asia, and excluding China, which obviously has been hit very early on, the other countries start exhibiting these first big challenges around March, April. So what we saw as a phase one, which is really to cover your bases. Everybody had to shift away from being on campus, staying at home, and accessing the systems from home, whether it has been remote working or remote teaching and learning, or now even on research. That has been the first stage, is just work from home. So Microsoft Teams has been very important in that because it's a key element of continuing the collaboration on the online world. Teams is essentially a collaboration hub from which you can have all functions that you need to work. You have video conferencing, you have your telephone calls, you have your persistent chats. You can show your status as free, busy, the present status. You can start sharing files. You can collaborate on documents. For example, you are co-authoring a paper and you need to collaborate in these research papers. And you do all this without leaving the environment. So this has been a great help because you are reducing the cognitive load. You know, you don't have to anymore to switch between the different apps to start working with collaborators. You have a single pane of glass with which you can collaborate. So obviously, during the first phase, not every research discipline has been hit equally. If you did theoretic work, then obviously what you need is just an internet connection and you continue to function. If you were in computer science or you're doing high performance computing for simulation, this is where you needed remote access. Now, what we found is that, however, remote access has not been a first-class citizen in research. So not everybody had access to that, or you had to jump through different hooks and loops in order to make it happen. This is where we saw technologies like Windows Virtual Desktop or WVD or Azure Lab Services have been key to ensure that you have this seamless experience, whether you're at the lab or whether you're working from home, which can be anywhere, and you can access anything, you know, whether this was a Win32 legacy app or you wanted to have hundreds of VMs. These technologies have been instrumental to make available the resources when you're working from home. So, as I said, a number of disciplines have been hit much harder. So if your discipline depended on having access to a lab, you know, whether it's chemistry or biology or field work, then obviously you have had a much harder time. Now we are in phase two in the customer's response to this pandemic, which now we call as the hybrid mode. So what we see is that some labs now with physical distancing are reopening, but this will be a partial reopening. We are not going back to the old where, you know, everybody was rubbing shoulders and you have all these people in dense environments. Then we have to operate in a reduced physical presence. So so this is changing. So productivity definitely will be impacted. Now, the second phase, is what we saw is that also conferences have been impacted, and conferences is a key source of information and how researchers conducting their own business. So a number of conferences obviously have shifted online, but there's a number of issues to make a remote conference successful. First, we have to realize that remote means that not everybody's on the same time zone anymore. You have an international conference, we have a 24-hour clock around the world, so wherever you have this conference, then obviously it would be, for some people, it would be in the middle of the night. So how do you deal with that? How do you make this successful? So, and the second challenge you have is, what do you do about the networking? You know, we don't go only on a conference just to watch passively the presentation of papers, but we network. So let me give you an example about how we dealt with it in our developers conference that happened a few weeks back in May, which is called Build. There we introduced a novelty, and Build has always been a physical event. And this year we shifted this event to a virtual event. And as a matter of fact, we have taken the decision to shift all our events for the coming fiscal year to online. So in Build, one of the novelty we introduced is that we made this a 48-hour event. So any time of the day you would dial in, you would find a live event. So we're realizing, because this was traditionally being run from our headquarters in Seattle on the West Coast, and the kickoff has been 11 p.m. Singapore time, or now 1 a.m. in Eastern Australia time, we realized that not everybody can participate despite their best efforts. What we did is we created a 24-hour event. So you could find an Australia meetup, for example, happening at a time which is appropriate for Australia and New Zealand, and you will have on every time zone. And this is one of the novelties that made this a successful conference. There has been interaction with teams. You would be able to ask questions, have a hands-on workshop. Still, obviously, the new normal would expect that we see a lot of more innovations around how do we network when we are doing things remotely. So these issues are going to be impacting the research output, and this will impact also researchers which will come up to tenure. And obviously there it's up to universities to recognize that these are extraordinary conditions and adjust appropriately and provide the time needed for these researchers, depending on the impact that COVID had. So I think that's one thing which we have now to realize on this phase 2. But thinking ahead, you asked me about the new normal. And what I see now as the new normal is that we have to design, to innovate about building a phygital experience. And by the word, the made up word phygital, which is an amalgam of physical and digital, I mean that we need anymore not to make a distinction between the physical and the digital experience. We have to remove the friction. We have to make this as easy to spend a few days at work when you have to think about and do some research, and when you need to go to the lab, you have to go there. But this experience cannot be just two different worlds, because otherwise the effectiveness of your research will be compromised. So we need to rethink about what's the phygital experience. Obviously, as we are entering very soon the second half of the year, then we have a lot of other additional impacts at the universities. We have obviously the reduction of revenues from fees, and we have the potential that governments might not be allocating budgets because they might need to shift budgets towards the economy or health. So we will have also impact from the political tensions. and this no doubt will also impact this particular part of the world. So what we believe is now universities should become much more data driven. We have now to understand in granular detail what is happening on a program by program basis. And for this, I would like to give you an example of the work we have undertaken with Purdue University in Indiana, United States. What we did is we used Microsoft technologies, Power BI, which is a dashboard democratizing access to business intelligence, and Power Apps, which is a set of technologies that allow you to get information from different systems and combine it, and then surface everything to Microsoft Teams, which allows a researcher to access these, whether they are on the laptop or whether they are on the phone. They now have access. What we did is we built a tool which is called the COVID-19 Sponsored Program Impact Application. So that's a mouthful, but let me describe what does it do, and I will make it much simpler. So what Purdue wanted to understand is what is the precise impact that COVID-19 has on their sponsored research. What is the impact from a researcher who is not able to access the laboratory, or someone who is stuck, an international researcher who is stuck in the other part of the world and is not able to cooperate. So they wanted to understand what is the impact of this research. So what this tool allows every researcher is it surfaces to a PI what are the projects that she or he has under their umbrella, what projects are responsible, and then it allows them, so it exposes customer information, and then the researcher can start indicating what's the progress that has been lost because of COVID, because you don't, for example, a deliverable has slipped, or some goals because you didn't have access. So now there's 1,100 faculty members at Purdue who are using it, and that allows them to go on a detailed level about what is the impact of COVID-19. So it's not anymore just a guesstimate about what's the impact, but it's actually now they can have precise data, and this data would allow them to go back to the funding agencies, to the federal bodies, and ask for supplemental funding. So it allows them to have a very good grasp on the research. And I know, Tim, that you have advocated for universities to do a better job to count what is the real cost of the research and understanding this. So my call to action to universities and the Vice Chancellor of Research is that they have to become now data-driven. The whole universities have to become data-driven, because now we live in these times. But VCRs, they have to become also data-driven, and they have to understand the cost and the impact of research, and it needs this hardcore data that we get to everyone.
So there's a lot to unpack there, and I'd like to go back through some of what you've just touched on. Maybe let's just work backwards, because I think that Purdue example is really interesting, and you're right, I have advocated in the past that universities do need to understand more, or treat their research portfolio more like a profit and loss centre, and they simply don't. I think in Australia we've seen the fallout from that, where universities have massively cross-subsidised their research portfolios from international student fees, and now there are huge gaps in the research expenditure capacity of universities, precisely because it hasn't been treated like this. Now, that's at the institutional level, but what you're talking about is also very different down at the project level for individual researchers and how they approach the administration and the execution of a project grant. So I guess I'm just wondering, this and maybe some of the other things that you've mentioned, how bigger transformation to the practice of research does this imply? And do you think that this will persist and perhaps expand in a post-COVID world?
I think it's clear from a number of other examples that COVID-19 is accelerating this digital transformation in all disciplines. And universities are not any different, because we are going to live with this for quite a while. And this is an opportunity for all these changes, which people have talked for forever, or at least for as long as I've been around. I've been talking about how to make things available everywhere at any time, being able to collaborate across the world, because your collaborators have not always been just in the same university, it has been everywhere. So people have been talking about this, but now this is a necessity. So this is clear that universities are not, as every other sector of the economy, will not go back to the old habits, and we have to look about what is the new normal. We know that a number of universities across the world, I think there's two options for universities today. Is either you will become an online, you'll be an online offering today for your students, or you're going to be on a hybrid model of learning, blended learning. There's not an option to become a physical only. So we're not going back to this. And we don't know for how long the vaccine will not be available. We have no idea. It's very hard for us to focus. So I think we have to understand that this change, it's going to be there beyond H2. And while everybody is now focusing on H2, because obviously the crisis has made us to look at this with a much more laser-focused priorities, I think we have to understand that we are going ahead with things which are beyond H2. So whether you're a researcher, or whether you're the vice chancellor of research or the president of universities, you have to make your plans about how you're going to operate through the COVID pandemic in a much longer term. So that's for me the first realization that people have to make. I think obviously some of the changes, if you're operating an expensive instrument, then obviously it's very hard to make this remote access. But you have to now explore. Obviously instrument makers will come and respond to that and saying, okay, this is how you are able to access, maybe including a robot arm to insert the samples and then control it. It will take time. But I think on where we are able to use some of these technologies that the cloud offers, whether you have to do your computational models, then you realize that having a box hiding under your desk would not make the cut, because then someone else has to power it up and down, or reboot it, or loading something. It's not anymore physical access. It's not going to be the norm. The norm is going to be a hybrid access or a remote access. We don't know how H2 and from there on how things will evolve. We will have another more closed down. So we cannot make any assumptions. So therefore, we have to rebuild, reimagine how we operate. And depending on a physical proximity, it's not going to be the normal. So the new normal has to reimagine all the processes in a university, whether it's teaching and learning, whether it's administration, whether it's research. We have to rethink about how we operate in this environment. Otherwise, we will have a tremendous impact on how we operate.
One of the really interesting possibilities there is the possibility of science without labs and without equipment, and the role of big data, simulation, new ways of actually doing the generation of science, so generative big data. And I'm obviously thinking of the Microsoft Academic Graph here. And I think traditionally we've treated those kinds of bibliometric data sets as either useful for research performance evaluation or for information retrieval purposes. But I think what Microsoft is demonstrating with the graph is the possibility of these data to generate new insights, and the overlay of machine learning on top of these big data sets, potentially, I'm not sure, maybe you can explain, but the role of high performance computing and large scale simulation that maybe we haven't had access to before. And do you see that that maybe changes some of the equation here, as in we've now seen some drug discovery done entirely within the existing literature. We've seen late last year the first patents generated entirely through neural networks utilizing these data sets, using the patent data sets. It's a completely different proposition, and it seems like something that should be more broadly adopted in the new normal.
Yes, that's great. And obviously, the shift to computational science has been going on for quite some time. It's not something that has started now because of COVID. As a matter of fact, I think that the science cycle we live, it's the data-driven paradigm of science. So what COVID is doing is obviously accelerating, and the way you referred to about Microsoft Academic is such a great example. So in response to COVID, we cooperated with a number of institutions, with the Allen Institute for AI, the Chan Zuckerberg Initiative, Georgetown University of Center for Security and Emerging Technology, the National Library of Medicine, and the National Institute of Health to provide timely access to COVID-related literature. So let me take a step back and really highlight the problem that you indicated. So the key issue is, what has been happening on knowledge in bibliographic sets and how we discover data. So academic knowledge has been doubling between 8 to 10 years, depending on what you count. If you count, preprints and so on. So it's been doubling. So we have an exponential phenomenon. A little bit COVID, I think people are now becoming more familiar with the power of exponential phenomenon because of COVID. So knowledge has been doubling every decade. So it's getting worse, and it has been a constant trend. There's a fascinating chart on Microsoft Academic side that shows how consistent has been this on a log scale. It's a very linear curve relationship between time and papers being produced. So it has been doubling constantly over the last century. So every decade you have to review double the amount of papers, while our capability to read has been constant. 20 years later, you have to review 4 times as many. So it's getting worse every time, every year. At the same time, we have a pressure to publish faster and faster. And that's why we have the emergence of new services like Archive and bioRxiv. And these have proven already very useful to crowd screen research papers. So we see increasingly people, particularly now with COVID, using these services to get the preprint version out and for people to review it. So traditional bibliographic tools, which have been okay, in the world where we were reviewing some well-established research journals, but now the academic publishing has shifted, has become much more faster, much more agile. So keyword searching has become from a help, from an aid tool, it has become now something of a hindrance. It has become a blinder. And I will explain that. So the problem is when you're using this keyword searches, is that you don't understand the context of what you're using. For example, take the term entropy. Entropy is being used in many scientific fields, and it's being used in physics, and it's being used in artificial intelligence. So when you're looking for entropy, which one are you looking from this? So you have to understand the context. Another hilarious example is my wife was looking for literature survey on serious games. And games, it also includes a human habit to go after geese and birds and so on. So she came up with some interesting but non-relevant information. So what do you do once you start getting this noise? You start excluding. So you do or, and then you do this minus, this, you start excluding. But when you exclude because you want to come to this 200 or 300 papers which you want to review with your team, when you start excluding and you come down to this number, you don't know what you have missed. You don't know what you have omitted from the filter. So figure it out. Let's ponder this for a moment. You have really, you're omitting and you're flying completely blind without understanding what you have removed. And we know that scientific discovery has happened a lot from innovation that has come and research that has come from adjacent fields. And what you do is now you apply confirmation bias and you say, okay, I've read 3 papers, then I'm looking for 100 more. They should look like the ones I have read. So you're omitting everything else. So you're going down with this tunnel vision, you're going down a huge rabbit hole, because that's the only way that you can keep the number of papers that you have to read yourself or with your team to a manageable number. So right now, this is what happened. That was the predicament that this alliance had to face. It had to face that we needed timely access to research. They could not afford for the long publishing, during COVID outbreak, for long publishing cycles, and then, with the reviewers doing this and coming back and forth, and then some editors in the bibliographic tools trying to classify them. This led to delays which are 18 months easily. Now, we cannot afford to do this with COVID. In reality, it's not only with COVID which we cannot afford to do it, is a lot of fields now depend on this rapid release of information. If you look at material science, if you look at artificial intelligence and computer science, if you look at engineering, medicine, all these depend on the rapid publication and evaluation of this information. So what Microsoft Academic Graph has done is basically to process anything that surfaces on the internet. So we have the privilege of having a web scale crawler, which is Bing, our search engine, which every day, every minute, it goes through the internet. So Bing surfaces to Microsoft Academic everything that looks like an academic paper. And then Microsoft Academic readers, it go and processing using network theory and using natural language processing, and it builds a heterogeneous database. And let me call it a database. And this database has today 237 million articles in it. And this changes every month because we are updating twice a month and we are updating with whatever is new. And I said, it's a database just to help understanding the classification, but in reality, what is built is a heterogeneous graphs. And graphs are very powerful knowledge representation mechanisms. And we know right now that whether you're talking about search engine recommendations or whether you're building a recommendation for your social networks, all these depend on graphs. And graphs are very powerful because they allow you to do not only the knowledge representation, but allow you to do inferencing on that. So Microsoft Academic is building a heterogeneous graph because it connects papers, authors, venues, conferences, journals, and so on. But it has some other innovation. I said earlier that it uses natural language processing. So what does it do is, starting from I curated an initial small set of curated concepts, it starts building what we call the fields of study, which is essentially what are the paper is about. So it is doing an inferencing on the abstract, on the title, about what does the paper talk about. And today we have constructed through this automatic methods 740,000 fields of study. So and also because it's a network, we don't have to rely on antiquated metrics, which is like citations, because guess what, a Nobel laureate citation of a paper and someone who is just a novice on that, they count equally as a number. But in reality, it's much more powerful. All citations are not equitable. So how do you do it? This using big data. We are using network centrality. You have a database and you understand the importance of a person, not just because I tell you so, because I'm an editor, but because you are able to see about how many papers are pointing to this author. And this is becoming, using big data analysis and the network centrality, to start understanding the importance of the paper. So not anymore just the number of citations, but looking at the network centrality. So fields of study, great. What does the fields of study allow you to do? It allows you to replace the keywords by actually looking at the fields of study. And let me give you an example. You might be, for example, looking for a paper that on artificial intelligence, and maybe a paper which is very technical, doesn't use that because it's talking about convolutional neural networks, because it might not be using the term. So on a traditional search method, this paper would be omitted because there's no mention of the fields artificial intelligence on that. What Microsoft Academic does, it knows that there is a parent-child relationship between artificial intelligence and convolutional neural network. And therefore, when you're looking for it, it would surface this paper. So fields of study is actually the mechanism that removes the blinders that I talked to you from using keyword searching. So yes, that's great. You might say, so what do you do? Did you build an incrementally better mousetrap because you just replaced keywords with fields of study? I'd say that this would be a gross understatement about what you can do and what is now possible with big data and natural language processing. If you look, I said that we have an exponential problem, which is knowledge is doubling every 10 years. You should not only look about what happened 10 years behind you, you should look about what's happening the next 10 years. If you're a researcher, that's what you should care. What's the problem? That the problem will get 2x bigger and more difficult for you in the next 10 years. And this 10 years is starting as we speak for every researcher. So what we do is, it's possible right now is to use natural language processing for machine reading. And this would be able to help you come and address more than these 200 papers, traditional 200 papers that the researchers are trying to home in, and surface the information which is relevant for you. So let me give you a couple of examples about how different researchers are being able to use this. Last year, there has been a number of papers which are being published about how researchers are using natural language processing, looking at chemical components database to infer the behavior of different elements and the bonds they are creating to design better drugs and the molecules behind them and train deep neural networks. There's a paper which has been using knowledge from reading academic papers on material properties. They looked at the thermoelectric properties of materials and they could actually start predicting. So not anymore about reading, or helping you to read, but actually becoming an intelligent assistant which should be able to predict what is happening. Another great example is Cochrane Institute in UK is using Microsoft Academic Graph and natural language processing to reimagine how they review the randomized controlled trials. So they're rethinking the whole process, and Professor James Thomas from UCL is using it to build a bigger mousetrap, because right now they can not only limit to the papers that is being surfaced to them, but they can use this bigger mousetrap to look at a much bigger set of papers, and a more effective one, because right now they can use the fields of study and they can do a better detection, and they can surface to the human readers sets which are much more relevant. So the whole way in which we will be discovering and working with knowledge, it's going to be disrupted. And I think every librarian, every vice chancellor of research, if they want to provide the right tools to the researchers, they have to use the power of data science, of the big data sets, and natural language processing. Libraries in particularly have been disrupted. We used to go to libraries because they had two things. They were a storage of knowledge. You could go and pick up the book, and they had the index cards. And then they had the microfiche. Now all these things have become irrelevant. But libraries have not been only about the physical means. You used to go to the librarian because the librarian would be the curator of this knowledge. They would help you find it. You were not just going there, wandering around and just finding. You had a desk. The modern librarian is a data scientist. And then the modern librarian, they have to reimagine the role and use the data science tools to be able to do curated search using big data like the Microsoft Academic Graph.
So it always struck me that in a similar way to the Cochrane Review, building a bigger mousetrap, that the world of innovation, and particularly patents and patent assessment and patent reading, is similarly able to benefit from this approach. And I know that the graphs incorporated a lot of patents as well. But that brings me to my next point, which is, I think that the other advantage that the graph has over traditional products like Web of Science or Scopus is that it's built on enterprise architecture, and it sits in an enterprise-grade stack. And that stack is used in universities, but across the private sector as well. As in, suddenly the graph is a translation point for research from the lab into applications. And I think that's part of the appeal of having a player like Microsoft in the ecosystem, is that you potentially can begin to replace lots of small bespoke systems that have only been sold to research labs and universities with the same functionality, but again on enterprise-grade tech stacks that are used over in the private sector. So suddenly it seems like the technology itself becomes a bit of a channel to get this stuff translated into applications. Do you have any thoughts or views on that?
Yeah, that's a great point, because right now knowledge is not only what is archived out there, but it's also what you produce internally. It's whether it's all your research report and your thesis and all the data sets that you're producing. And therefore, if you are an institution and you're thinking about how do you access knowledge, you should not be able to think only about what's out there, what's being published outside, but you have to think about what's also on your heritage, what you have produced internally. And this internally can be archived in the library, or it can be your researcher collection, It can sit anywhere in a university, and you should be able to treat this with the same way. So you should be able to access it. You'll be able to use the same natural language processing techniques and actually provide an overlay of the knowledge of the institution, the knowledge that sits on your own environment and the outside world using a common framework. And you need there an enterprise-grade architecture, and you need the elements of these cognitive services that allow you to process them. So today it's actually possible to build this overlay, which would be available at an organizational level, but also on a personal level, because let us not forget, it's not only about the information. The information is not only in public form, but it might be information which might be available inside the university only, or it might be on my own personal information, which I don't want to be exposed, but I don't want to limit the access. So how do you work in such a case? Then you need an enterprise-grade framework, which is using Active Directory that marks its paper and surfaces it only to the people who are entitled to. So it doesn't surface it outside, or it doesn't surface it to other groups, or it doesn't say to other individuals. And you need the enterprise-grade architecture like Azure Active Directory to do that. Then the second one is how do I process this information? Some of this information can be electronic, some of this can be in PDFs. Well, then you need to have the OCR scanners and to be able to understand the format of the paper, parse the paper, and create the right format. Today, it's possible to reuse the same technologies that we have applied to the outside world, we have applied in Microsoft Academic, and really use it to parse your own research, or the research that you have in the library, and have then an integrated system that allows you to expose this, but at the same time having the right safeguards in place about the information access. And as you said earlier, this information can have many different forms. It doesn't have to be an academic paper. It has to be notes, it can be a data set, it can be anything, it can be a patent. You need to have a common framework that you process all this information.
I think the idea of a common framework is key, and I think it's similar to standards. So you can't have the internet without the existence of HTML as a standard that's broadly adopted. You don't get scalability without those standards or common frameworks. And what I see again is the potential of something like this being able to actually get research out of the universities and into the hands of users and into their archives and libraries of documentations like you suggest. And I think that's really exciting. Go.
Yes, we are just at the beginning. I think we have to realize that libraries have been disrupted. And I really believe that the new form of the library is a very exciting one. It's a very exciting one. It's a completely different new skill set, but that skill set is now very relevant. So I think it's going to be very exciting to see how libraries now are able to get out of this gradual situation have been coming through the internet disrupting what they have been doing, and now being relevant again, because the role of the curator, of the advisor, has never before been as relevant as it is today.
If I was a librarian, or if I was a university interested in speeding up the translation of my research into applications and working closely with industry, I'd be looking at how to integrate my institution's data sets and bibliographic information, make that accessible to industry partners who can just dump, again, in a common framework or a common language, their own documents in and just have the expansion out from there, so that the opportunities to collaborate are surfaced. And that's really what we're talking about. I think opportunities being surfaced that otherwise you have to really go through slow processes in order to to get access to these. I think it's a really exciting future.
And that's a great example that you're showing there, because if you're really wanting to collaborate with industry, with our organization, obviously a lot of the research has titles which are very narrow, because this is the nature of the beast. The research is very, very specific. So even translating the type of grants that you get, the type of research, and using the fields of study to be able to mark them, to tag them. So when a company X comes to the Vice Chancellor for Innovation and External Relationships, and I say, I'm interested to do X, Y, Z, then the mapping of this X, Y, Z that they're interested is going to be very, very straightforward against specific researchers, initiatives, against specific papers and researchers, so it would make the matching. So obviously, exactly as you said, the use of this technology is across opening the university to industrial collaborations. So this can be the same technology that you use for this purpose.
I'm conscious of time. We've only got a few minutes before you've got to leave. Was there anything else that you wanted to mention in particular?
Yeah, I think right now, obviously, I don't want to make just a political and statement, but obviously we live in very interesting times, and obviously it's a crisis, and as Winston Churchill has said, never waste a good crisis. So we should see that this is an opportunity which we reposition ourselves. If you're a university, it's an opportunity that right now you can break the norm, you can rethink how you're doing things. So a crisis, obviously we don't underestimate what's the importance of the financial disruption that is being, is now underway because of primarily of the international student fees. I think governments need to help. They need to step in the same way we see governments stepping in to help airlines recover, and they should also look about how they can help universities. But also it's the responsibility of the universities to come with data-driven points and really prove about the impact of the research, but also how they are taking a broader role to restart the economy. So it's a huge opportunity, and I see with pleasure a lot of leaders now thinking about the wider responsibility that they have, not only to continue their operation, but to think about what is the role in the post-COVID world and the new normal.
And with the last couple of minutes we've got available, are there some examples that you can point me to of interesting things that are happening and who might be rising to that challenge?
It's a bit too early, and I haven't got permission from the people I've been working to share some specific examples, and I have some specific examples from Australia, and I'm very glad about that. I think Australia for Asia is one of the lighthouses. Australia has been hit very hard, but I see now leaders looking about this new expanded role and the new opportunities that they have to step up about how do they help enterprises. And we are open to partner with these universities to help them on this, because it takes a partnership. It's not anymore a buyer-supplier relationship. It's not a vendor relationship, but it's more a strategic partnership. It's a three-way partnership between us, a university, maybe enterprise or association of enterprises. Whether this is about skilling, it's the same about research. We have to rethink about how do we make this open, more accessible. We are democratizing this access. The same way we're thinking about the skilling initiatives, I would like to say we should think about how do we drive research impact to the economy, because higher education is really the lifeblood of innovation and competitiveness of economies. That's the reality that we should have. Everybody, every political leader and every academic leader and every enterprise leaders should have in reality that the work that has been happening in research in universities is the lifeblood of innovation and future competitiveness of economies.